Dear students, in this particular session, we are going to design a robot using open source simulator, which is CoppeliaSim. So you can, as already discussed in the class, you can easily download this CoppeliaSim software. Sim is for simulator from the Google directly. So after downloading the software, you will get this kind of window in which this particular area where we are going to put our robot is known as floor, and the complete picture is known as scene. So here you are able to see that this file is known as scene. So whenever you are going to create new scene using robot, that will appear in this particular file. So few already you know about the few uh, tabs and buttons which are available for use. So in file option, there is one feature you can directly open recent scenes, whatever you have done. So in this particular, as an example, I am showing you this file in which we have already designed a robot. We can play this robot using this play button. So in this particular session, we are going to design this kind of robot which can stand and which has different sensors and wheels. So if we give the velocity to the motor, any motor, either left or right, so how we can give the velocity? Just click this symbol, motor symbol, double click, and then go to show dynamic properties. And here we can give the velocity 50, 100, 200 as per your choice. And you can play the simulation button, display button. So why display button? Now you are able to see that it left motor, because of left motor velocity, this is able to move in this particular direction. So similar way we can give the velocity to the right wheel as well. So this is basically stop button, just adjacent to the play button. And when you want to get the all the designs in the original position, just click this stop simulation. So when we stop simulation, then the robot will come on original position. So with this kind of robot we are going to design. So now let's start with the new file. Easily we can open, go to file, go to new scene, you can open new scene. So first we want to add that big sphere in the particular screen. So first point to remember is that this scene hierarchy should be open, then it is convenient to select the object and to make different changes directly. It is convenient. So if this is not appearing like this in this way, then you must go to this left side, and there is one scene hierarchy button is there, which is from bottom in fourth position. Just click this, then you will get this particular scene hierarchy. Now to add this robot, there is certain procedure which we are going to follow. Right click. To add any object, the procedure will remain similar. Right click, add, go to primitive shapes, select sphere. Now what we want to give the diameter of this sphere. I am taking 0.2 as the diameter, and click any other box and OK. Now on the screen you are going to get this sphere in the screen. Second step, when you get the object in the screen, you have to check for the properties as per the requirement. So to change object properties, there is one symbol, just blue symbol is here. You have to double click this particular symbol, then go to common and make this robot collidable, measurable, and detectable. This step you have to do. Then only this robot can be designed as per the required properties. Now cross this window directly. We don't need to press any enter or any else button, any other key. Now second step is, first we have done the change the property. Second step is to rename the object. Always we are going to rename the object because we may have more than one sphere in the window. So just to rename, we need to double click this particular object and write the name. Here we are taking the name as bubble. R should be in capital. Rob. You can give any name of your choice, but here we are going to apply some codes in the last. So code script will be there. So as per the names should be similar in this particular file and this that those codes. So that's why I am taking some nomenclature for these particular object names. Okay, so now one point is here to remember again that you have to click enter when this cursor is inside the box. If you don't keep the like this, then this will not get renamed. Okay, so now we have renamed the object as bubble wrap. We have changed the properties. Now next uh, third important point is to change the position. So here this is just below modules. There is one button four-way cursor is showing. This is basically to shift the object to change the position coordinates in XYZ direction. So just double click this position. After that, here we have to choose translation. After translation, here what we are going to do, we are going to change Z coordinates only. In Z, I am giving 0.02. So by changing these coordinates, we are going to shift the sphere in our direction, in Z direction. So why we need? Because we need to connect wheels in the end. So for a movement of those wheels, this sphere should be above floor. So click any other square box, as I always say, to click any other square box so that these values will be get same. Now, after giving this value 0.02, once again I am giving the value 0.02, click any other box, then translate selection. Click translate selection. When I press, just one important point is here. Click this button translate selection only once. If you click it multiple times, then it will always shift by those coordinates only and it will not be aligned with the wheels later on. So that's why we need to click these all translation button only once. Now, so all the three tasks we have done with this sphere. Now what I want here, we want to attach this particular conical type proximity sensor, which is going to sense the objects later on. So again, the same procedure is there to add any new object in the window. Right click, add. Here you are able to see proximity sensor just below graph, and we are going to select cone type proximity sensor. Click cone type. Now what you are able to see here, this is in upward direction. What we want? We want this should be in forward direction. So here we have to change the position as well as the orientation of this particular object. So always make sure whatever object you are working on, that should be selected by this highlighted yellow line. So again, next step is to change the position and orientation. So again, this is the position tab. Click this position, go to, now here you have to make sure, now onwards you have to click position sub tab always. This you have to make sure that you have to click this position sub tab always, and then you have to give x as 0.1 and z as 0.12. 0.12. Click. Then after this, we are going to change the orientation. For orientation, click this orientation button here. Orientation, go to orientation window. Now give the angles beta. Don't change the values of alpha. Just change beta as 90 degree and gamma also as 90. Click any other box like this. So up to here, the conical type proximity sensor is here. Now next step is to rename this sensor. Again, the same procedure is close all these pop-ups always. Double click this proximity sensor and I am giving the name as sensing and capital nose. Sensing nose. Again enter. So next step is to change the properties. So how to change the properties? To change any object properties, you need to click this particular small symbol again. So I am going to double click this symbol. Go to show volume parameters here. And here we have to give offset value as 0.005. 0.005 offset value, then range 0.15, then angle 30, 30. Now what you are able to observe here, that sensing nose present here and this structure has been changed. So after this, close this window and we need to again either we can use direct this pop-up show detection parameters. We need to click here, show detection parameters. We need to click here and we have to check that don't allow detections if distance is smaller than this as unchecked. This make sure this should be unchecked. Now okay, and now cross. Now next step. So all three steps we have done with this sensing nose as well: property change and position and orientation, renaming. All these steps we have done. Now we want this sensing nose to be the part of this bubble raw. So bubble raw will work like parent object and all the other objects will work like child to the bubble raw. So there is certain procedure which you need to take care of. Always select the parent in last. So first I am selecting the sensing node, then pressing the control key, then selecting the bubble raw, right click, go to edit and make last selected object as parent. Means, so whenever you want to make any object as a parent, then you have to click that parent in the last one. Now you can see the hierarchy. This sensing node has been connected with the main bubble raw. So up to here we have done with the body, main body of the robot and this particular sensor. Now next part is to add the two wheels here. So always we can add the wheel here as well, but when we keep the put the add the particular wheel here, then it will appear just behind this main body of the sphere. So it is always advisable whenever you want to add new object, open new scene and you can create that particular object here, and after that in the end we are going to copy and paste those objects in the main window. So this is basically working like our main window. So I can save this file as main bubble raw. Go to file, save scene. How to save the file I am showing you. Save scene and you can save scene this, just I am writing here main bubble raw. So this is the main file. Here we are going to do remaining changes. So in the new scene I am going to, and here we need to add the wheels. So again to add the wheels, go to add, go to primitive shapes, and wheel shape is basically cylinder. So here we have to take cylinder only. So cylinder will have two dimensions, x and z. In x you have to give 0.08. All coordinates, all dimensions are really aligned with the main object. So that's why we are taking these predefined values only here. So click and OK. So now you are able to see this particular cylinder, but this is in horizontal plane. We have to change the position and orientation as per our requirement. So this is whenever we add any object in the window, that will be by default selected. Even if you are not sure, always select the object first, then make changes. Okay. Now again here I am going to change the position and orientation. First I am going to change, first we can change the properties as well. Just click this shape and here we are going to common, and again we are making it collidable, measurable and detectable. Cross. One step we have done with. Next is to rename we can do. So left wheel, I am giving the name. You can give the right wheel as well. So here I am giving the name left wheel. So coordinates are according to the left wheel only. W is capital. Remaining are, because this is case sensitive, so remaining are in small. Enter. Now click position button. After clicking this position, you have to make sure that this should be selected position subtab only. Otherwise, you will change the different values, then it will not work. So X I am going to give 0.05, Y is 0.1, and Z is 0.04. 0.04. Click any other box. So we have given the values to this particular position. Now close this pop-up window. Similarly, go to orientation. Check that orientation tab is selected or not. If it is not selected, select the orientation sub tab only, and then change the alpha and beta and gamma. Alpha is we are giving -90, beta and gamma are 0. So change these values as well if these are different values. So that right now here 0 is there. So we have to give 0 and 0 to beta and gamma. Now go to rotation and click rotate selection. Now we need one more wheel in the window with the same properties. So there are two ways. Either we repeat the procedure or we simply control C and control V in the window. Then rename this new wheel as right wheel and enter. So this will have the same properties of collidable, detectable. This you don't need to do. Position, coordinates are same, and orientation is, you can see that it is same now. If we add it in new object as a cylinder, then the orientation we have to change. So that's why it is easy to just simply get the same property wheels directly by copy and paste. Now one point is here, both the wheels have collided to each other because of the same coordinate, position coordinate. To select right wheel, then go to position, and after going to position, just change Y. Check that position should be selected. Change Y coordinates as minus 0.1. Minus 0.1. Now you can see both the wheels are separated and cross. So we have got our two wheels in the window. Now select both wheels, right wheel and left wheel, control C, or we can do one more thing. We can add joint, either taking these wheels to the main window, or we can add joints here as well. So right now I am selecting these two objects here and control C and going to the main window and control V. So both the wheels are appearing in my main bubble wrap window. Now next step is, fourth step is to add joints, means motor. So to connect these particular wheels to the main object, we need motor as well. So here what we are going to do, just right click, add, go to join. Here we are going to choose revolve. So when we select this revolute join, this is, you can see by default gets selected. And now we can attach this revolute join. You can give directly renaming here as well. So I am going to rename here it as left motor so that we should not have any confusion. Left motor, M capital. Now select this left motor and press control button, control key, and click this left wheel. Click this left wheel. Both left wheel and left motor should be selected. Click orientation tab. Go to orientation and click apply to selection. Click apply to selection. Similarly, we can add another wheel by just clicking. Same step you have to do for position as well. Go to position while both are selecting, apply to selection. So now you are able to see we have this joint, red joint in left side as per our required condition. So this is the main, here you are main robot. So here you are able to see these motors connected like this to the wheel. So here as well in this particular file, these has been connected. Now similarly you can repeat the step. Click right, add, joint, revolute. I am going to rename this joint as right motor, M capital, right motor. Select this right motor, right wheel, go to position tab, click this position sub tab, apply selection. Again go to orientation, click this sub tab of orientation and apply to selection. Now both are connected to respective wheels. Both joints are connected to respective wheels. Now here what we are going to do, we have to change properties as well. So click left motor, go to show dynamic properties and you have to enable motor. Till now it has not been enabled, it has not been locked. You have to lock motor. Also when target velocity is 0 means it should not move when velocity is 0. Cross. Similar steps you have to do for the right one as well. Click symbol of right motor, go to show dynamic, motor enable, lock motor and close. Now what we want to connect this motor and the wheel. So first select left wheel first because we are going to provide power from the motor only. So we have to select the motor in the last. So click left wheel first, then control, then left motor, right click, edit, make last selected object as parent. Repeat the same steps for the right one. Click right wheel first, then control key, then right motor, then right click, then edit, then make last selected object as parent. So up to here, we have got this kind of robot. Now if we play this robot, then you are able to see then everything is going apart. So we have to add, so I have clicked this square button. We have to add this right motor, left motor with the bubble rope. Bubble rope should be selected in the last. Right click, edit, make last as parent. Now if you play, then you are able to see that this robot is going to behind side. It is falling in this backward direction. So again I am clicking this. So but now these wheels are not detaching, motors are not detaching because we have selected all these as bubble child. So now next is to provide some support system in the backside. So here we are going to provide supporter in the backside. For that we are going to open new file, new scene. In new scene, this is the step 5. You have to click right button, add one slider we need to connect. So this primitive shape is fair. So this slider should be of very less size from the main body. So the dimension of the X is 0.05. The diameter is 0.05 now, and OK. The remaining steps are same. We have to change the properties by clicking this symbol, go common, make it collidable, detectable, and measurable, cross. We have to rename, again double click. So I am providing the name as slider. It's all in small letters. Enter. Now again I am clicking this property button, going to show dynamic properties. So in show dynamic properties, there is one option, edit material. Click this material and we have to give friction 0. So friction should not be there. So at 5 places we can see that friction word is written. So at these 5 places we have to change the value of friction as 0. 3, this, and last 5, and cross this window. After this, I am going to connect one force sensor, so that the role of that sensor will be to detect the force, to sense the force. Just cross this pop-up window and add new object, add force sensor here. Now you are able to see this green circle in just below the particular slider. Here next is to rename, because this is going to be like work like a connector. So I am going to give its name as connection. So all the spellings and everything should be correct, and only our code at the last and third part of this particular robot will work. Enter. Now we need to change the position. Go to position, select position and Z coordinate at 0.05. After giving these values, you are able to see that green connector will come above the slider. Now we select the slider first, then control, then connection, and make connection as the parent. Make connection as the parent. Here you can check the hierarchy and control C. Select both objects, control C, and go to main window, control V. Control C and control V. Now go to connection, select this connection basically, go to position and give X coordinates as minus 0.07. Now you can see that behind the robot, that is connected behind the robot cross. Now select this connection, control and bubble rob. Again make the bubble rob as parent. So now all the things you can see, all objects has been connected with the main bubble rob now. So now we can check that our robot is working or not. So now it is okay. We can give the velocity, we can check to any of the motor. I am giving the velocity to right motor right now. just for checking that it is working fine or not. So now you are able to see that robot is moving on the right wheel. Stop simulation. But one point is, if zero velocities will be there, that time that robot was moving, little bit moving, or we can say little bit vibrating. So that time it was not stable. It should be stable. So for making the robot to be stable, we have to do some more steps. So I am going to explain these two also. So first what we need to select the slider. Just select the slider, double click the symbol, go to show dynamic property. Here you are able to see local respondable mask. So here what we are going to do, we are going to do 0, 0, 0, 0 and 1, 1, 1, 1. Well, it means you have to untick 4 initial boxes and you have to get it remain ticked the next 4 small boxes here. Now cross this. Similar way, select the bubble wrap. In bubble wrap, go to properties, go to show dynamic properties. Here what we are going to do, we are going to mask it. So here we are going to give 0 to the opposite side. So lower 4 bits we are going to give the 0. This will be like 1, 1, 1, 1, 4 times 0. Cross the window. Now select left wheel, right wheel, control, right wheel, bubble wrap. Here we have to select both the wheels and the bubble wrap. Go to tools, tools is here, and go click this first scene object properties. When you click this scene object properties, go to show dynamic, then you are able to see the mass of this robot. So here we are going to adjust the mass of robot. So you have to click this M into 2 three times, 1, 2, 3 times only. In the similar way, we have to adjust the inertia as well. So 1, 2, 3. Now we are going to play our robot. Now I have given velocity to right motor again 0. When we play this button, and now you can observe that earlier robot was just moving uh, from its original position, like vibration was there. The everything has been set now, and you are able to see the simulator is running, but still robot is not moving at all. So with this kind of robot, we can proceed the next set practical. So this session is up to here only. And in the next session, we are going to discuss how to add uh, different vision sensors. You can see I am just quickly showing you the final version which we are going to design. How to add this graph, how to add this camera sensor and obstacles. So I am going to play this. Here you are able to see this robot is working like an object detector, like an object detector. So camera, we are able to see the view. So this will be completed in the next session. So thank you so much and follow the steps. Thank you.